All right, so if I could have a few minutes of your attention, please. So this was not a very difficult algorithm to produce, and everyone pretty quickly came to the right idea. So the word that I was able to do with my spell pieces was this. They didn't give me an X, but that's okay. So so here's my paperclip, and so it's a consonant. So I just move on to the next. It's a vowel. So then, with the tiles, it's nice. I can just physically move the thing somewhere. Then I have another one, so I stick it afterwards. And move my paperclip, move my paperclip, move my paperclip. There's another one that I get to copy here. It's not a vowel, and I'm done. So that's my basic algorithm, but it's kind of more fun to play it through with the tiles. And I really highly recommend that when you have an algorithm that does something new or that does something unusual, if you have Scrabble tiles, they work great. Playing cards work. Poker chips. The kind of thing. Probably potato chips work if you write the letters on them. Whatever you happen to have at home. Because when you do these kind of physical arrangements, it's easier on the brain than if you just stare on a piece of paper. Staring is bad. Writing is good with your hands, but actually playing something out, arranging objects, tends to be a better way of getting some intuition. And it's not a natural thing for people. People are so accustomed to, from calculus, that you must stare very hard at the page so that the answer will jump at you. I mean, that's what they teach you in calculus. That you just have to really get yourself to the kind of more playful mode to come up with these things. So, and once you see it, then it becomes pretty easy to write up the pseudocode because you now have a bit of intuition as to what this thing does. How many times do you loop over it? This one was pretty simple. There was just a single loop over this. And also you see that some results got longer and longer. So in your pseudocode, now you kind of expect one loop, something gets longer. And so we'll see what now happens. So now I'm going to write my pseudocode, and I want to somehow express that I want to loop through all of the positions in the string. So I could say for I in all positions of the string. And then later when I code this up, I can say that actually means I starts at 0, I is less than the length, and so on. But I could just write it like that because that's my intention. I want to go through all of the positions. Maybe I could even say, from 0 to end. Some phrase that says, I want to go from the beginning to the end, all valid positions. So now, and this is something where several people have trouble with. Now what do? I want to look at the ith character. And before showing you how to do it right, I'll show you what several people did, what I consider not right. Several people said, if I is a vowel. Okay, why don't I like it?
Because I isn't it's not a string.
Yeah, I is a number. Is 3 a vowel? That's like E backwards, so maybe it is. So it's not that I is a vowel, it's the character, the ith character. And so then some people said, okay, if the ith character is a vowel, and then they said, result equals result plus the ith character. And that's fine, but now when you see yourself writing this thing twice, then what should you do? Notice I said, if the ith character is a vowel, result is the result plus the ith character. Make it better.
But doesn't that work, though?
Yeah, it works. Yeah, it works. But I said something twice. I said something twice. The ith character. The ith character.
Wait.
Yeah. So when you don't want to say something twice, you instead create a variable. Right. And so this is something that you can now notice that this is a beneficial thing to do. So you can now say ch equals ith character. And so then we can put a ch in here, and we can put a ch in here. And if you use a pencil and an eraser, then you can just do that really easily. And now you get a pretty good idea of what the structure of your thing is. So let's again see, is it what we played through? We had a for loop that goes letter, 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 letter. Each of them gets stored in ch. Each time I say, is it a vowel, is it a vowel, is it a vowel? That's here. And when it was a vowel, then the result gets longer. That's the piece of code here. So that means that I now have a pretty good confidence level that this is the actual pseudocode. Now when you put it into the computer to actually make the program work, there is like an overwhelmingly good chance that this stuff is just going to work. There may be a syntax error or two, there may be an off by one error or so, but the basic idea is going to work fine. So let me apply the same idea to another homework assignment that we have. I realize it's a little unfair to do it after the fact. Consider that problem of reversing a string. So here are my 7 tiles. And now I want to do the reversal thing. And which one do I start with? So, and now I'm going to have my tiles here. Where the heck was my cue? Oh, here. So, this is not going to work very well in the video, of course. Where am I going to put them? Okay, I don't know how to do it. So, you're just going to have to imagine that I'm holding them. And so now when I want to move them together to compose the answer, it really calls the question. Do I look at this one first, or do I look at that one first? And when you have them physically in your hand, lined up, and you have to move them, you have to do something. You can't just keep staring at it. So, give me one. Should I move the B or should I move the Q?
The Q.
So, we're going to move the Q. Okay. So here, just imagine me moving the Q. So that means I must have had, my paper clip on here, because otherwise how would I have been able to see it? And now what do I do with the paper clip? Do I move it forward or backward? I move it backwards. Okay. Then I'll get the A. Where do I put the A? I put it after the Q. Okay. So I move my paper clip here. I have the W. Where do I put the W? I put it after this thing again. And then you can kind of see how the pattern evolves. So let me write my pseudocode. For I going from end to beginning, pick the ith letter. And so now I'm smart enough to give it a name. And is it result plus ch, or is it ch plus result? This one or this one? It's the first one because I want to put it after, right? After. This one would be putting it before. So there is your solution for that assignment. And you can see, if you just play it out, it's pretty easy to see how you do it. Now, of course, then there's the technical question: how do you do this pesky loop? So now we leave the realm of pseudocode and go into the realm of Java. So now you have to know that in Java, this is 4 int I equals, okay, what is the last character? Let's say, I don't know if it's what's called str, but for now it's called str. Length. He says string.length minus 1. I take that as a friendly amendment because string.length is not a valid index. What else? Something wrong.
Like keep going till as long as I is greater than string length or something.
So now he says keep going. We didn't have the keep going part, right? So the for loop has 3 parts. The minus minus is really only the 3rd part. Oh no, semicolon. So what you're saying is I have to do what? I have to check while I is, you said less than the string length?
No, it's greater than.
Greater than. Greater than makes sense, right? Because we're going down to 0. Greater than what?
String length minus 1.
Yes, no?
Switch the result to 1 plus result that have to do.
So we're going this way, right? So we've determined that we're starting at string length minus 1. And if it's too abstract, let's take a number. This thing here, string.length is what? What's the length of the string? This particular string, what's the length? 7. Alright, so the positions are 0, 1, 2, 3, 4, 5, 6. We're starting at length minus 1, length is 7, length minus 1 is 6. Should we start at 6? Yes. Okay, when shall we end?
0 when it's less.
I would kind of agree with 0, right? We should end at 0. So is this the right condition here?
No.
Is it close? No, right? It's not even close. So, but, hey, no one else had an opinion. He had an opinion. But it can't be the right condition because we're starting at the end, so we need to move ourselves forward to the beginning. So what's the condition?
I is greater than or equal to 0.
He says greater or equal than 0, and that is in fact correct, right? Because we want to pick up the 0. So, in this loop, which values, let's say that the string is in fact exactly what it is over here, that 7-letter string. Which values does I assume? You carve out a little multiple choice question here. Your choice A, 7, 6, 5, 4, 3, 2, 1, 0. Choice B, 6, 5, 4, 3, 2, 1, 0. Choice C, 6, 5, 4, 3, 2, 1, 0, minus 1. And choice D, 7, 6, 5, 4, 3, 2, 1, 0, minus 1.
B.
Okay, who votes for A? Nobody. Who votes for B? Okay, no bunch of people. Who votes for C? All right, so why is it C and not B? So why is the minus 1?
It assumes that this is.
Yes, exactly. So it assumes the minus 1. This was a question on one of the quizzes, and someone asked about it. It assumes minus 1 because it is 0, and then for a fleeting moment, it becomes minus 1. Then, of course, the minus 1 fails the condition, and it dies. But for a brief moment, before its death, it actually is minus 1. It is tragic, right?
Even though this doesn't exist, it just thinks it, right?
Well, no one has observed it except for this little condition, right? Only this one here has been a witness to its change, and then it died right afterwards. So that's the way it is. All right, that's what I have for today.